Okay, people, I want to give you a heads up where I'm going. I have a lot to go on this upstairs for you. For example, we have this rush that by the air conditioning units to go all the way through the structure. It's not just there; it's at multiple locations. So I have a lot to give you. That one's major there. I have a lot to give you on the structure. Plus, we have to find leaks and more. By the 11th floor, this being the 12th, this being the 11th, the underside of the 11th floor shows the conduit going in that direction. So there was a tug of war going on with this structure from the 12th to 11th floor, back and forth. And we even have it at one point, considering the firemen didn't push this out, considering that part of the railing was significantly deformed outwards at that level. Considering the firemen didn't move it when they were going up in the air, that they didn't flex that. I can't imagine they did. I guess I imagine it, but I don't think they did. So as you may see, you have the conduit in that direction. You have conduit in this direction, and you have this is a right there is where bend is. So this conduit was up there before it took another it was up there when it had the original bend. It was at the flooring, and then the flooring broke off, and then we get the secondary bend back here in the back row. So let me zoom in for that for you. So you see the bend in the conduit. So initially this conduit was further out. If you could sit it back up, it was further out here on this off of this flooring here. It bent, released, and then when it was hit again, it then gave this other radius here. It wasn't bent there and then smacked again. It's consistent with it. Well, yeah, you know what? I'm looking at that. Yeah, it's consistent with sort of like that. Multiple multiple bends and so here and here I would say the two planes are. So then I would pick my poison on which direction caused did it come from this direction first and then secondary bump caused that one, or was it this direction and caused that one? Pick your poison on that one. We have, let's see if I can get this right. I believe this is your sprinkler system, maybe right here and here. And if you can see the angle of them, they seem to be about the same angle. So now you're starting to get a profile of the floor failures. I don't want to be specific about rooms, sensitive to the people there. Remember, this wall system here is just that's the elevator shaft. So they look like the reinforcement goes like that, and it was obviously a lot of it was pulled out. A lot of it was pulled out and popped out. And we then have the reinforcement. So we then have what I call the scars. You remember scars? So this is a scar. I'm going to remove it. Scars on the wall. And you can see the brushing like that on this wall here. You can see the scars. So let's do it again. Let's zoom out. And now you can see the scars. And you see the direction of the scars. So you can see it starts telling a story of the floors and how they pulled in. And those scars are about parallel. These scars with these. Remember the front of the building on the other side was holding on. it was holding on. This is tied from the front to the back with the reinforcement. And it had a tugging effect, and that's why you see that back part go down last. It had a tugging and made a radius. Say here's the floors here, right? So it held on here, and it created an arc like that. Using these scars, it created an arc like that by holding on from the floors in the back. And if you look deep enough, let me see if I can find, this is what we're going to get to. Again, we're going to come back to that. That's the steel that went across. That's the door. I want to find you the scar. Hold on. It was a nice deep scar. So these are steel scars. The reinforcement, rather. I think we see them better with the shadows on them in the daytime. So you can see the way that floor behaved, and it was pretty much flat at that point, straight down. And you see the panel here, and that panel here, I call it a panel, but floor. You can see how it's not pushed forward, not backwards. It's in line. If you could lift it back up, you'd be able to put it back almost close to the wall again. It's not diagonal like that. It's not diagonal like that. It is flapped over. Okay, the failure was not here. It was out here that the impact and the rebar broke. Well, it had reinforcement, remember, but it's still hanging there. So he couldn't hold his cantilever anymore, such as here, because this floor goes across. Remember, it goes across onto the rest of the roof. Whereas this one, the cantilever I'm speaking of, there is none. It just mounts directly to that sandwich here, right here between the floors. Right there, that's a floor. That's a floor. As you go down, that's a floor. But that is literally the floor and the ceiling of the room below. I don't want to make this personal, so we won't dive down to exactly whose room they are that we're looking at. All right. So now you're getting a picture of it. You know what I love the best? When I go on and on with content and I forget to press record. Okay. So I'm not sure where I left off, so let me just go ahead and try to give you the short version of the steel here. I said, look, you got to go back to my video talking about shear failure in concrete. Most people see it like that, and they said shear failure. I state that during deflection, your rebar experiences such stress during the deflection that the steel and concrete separate from each other. They explode from each other. And that will show in a crack like this. So I say this is number one. You can try to debunk me on this. This is one. And then secondary is the crack that climbs back to the load point. This is two. And this crack is what defines the whole thing as shear fractures, everyone says. But I'm stating that it's first. It is a shear down here on one, laterally across the steel, happening first. I'm stating that if you look at the door here, there's some rebar like this, and it's straight. It's 90 still. If the concrete was still bonded to it, and I try to give hints to this stuff earlier in other videos, if the concrete was still bonded to it, and the concrete was to pull on this, it would want to straighten this steel out, would it not? What happens if it's starting to straighten the steel out before it releases? The steel looks sort of like that. That's what you get when you're getting steel that is still holding on. It does that. It doesn't straighten fully out. It does this before the release happens. This steel, as I showed in video 2 or 3, it seems pretty clear. It's clear to me. looks like 90s. It looks like they're still developed, which means to me, deflection took place, a stress took place that caused this to, with the 90s, however they turned in up. The stress was so great that it, under deflection, that it was able to burst it. That means that at number 102, I believe, is, I show that in video 6, here's G, and this is, I think it's designated beam 101. This is very hard to determine if it's beam 102, but I think it's 102. It's the one that goes back to here. Beam 102 is just a transfer beam because there's cantilever action going on to this corner. Let's look at the top view of it, okay? So top view, and this part here is this part. And then this comes over. This is not over the G. This just comes over to the roof, to the corridor. But there's a cantilever, and this cantilever has two pieces of rebar. That didn't work, did it? Two pieces of rebar that we're looking at right here. And I believe they're like that. So they look like the 90s are still in shape. So I can adjust this if we get a better image and it doesn't look like in shape. But right now they look in shape to me per my video 2 or 3, whichever one it was, which indicates that there was some serious deflection in that roof trying to hold on before it did what you guys call a shear fracture, but I show you what I'd call it. It did the number 1, 2 thing. First one down the steel and concrete, bursting it apart. Now that leaves it under, so the concrete looks like it just came apart, like it was never installed. It looks really, beautiful. And then you get the ejection. It would be nice to have that piece of steel to measure to see if there was some stretching in there, some necking in that steel, but the building was collapsed and we'll never see that. But you also notice that the door was folded over, so there was some deflection. It all went all the way down to the wall there, while it held on, and it released. But it bent the door down. It folded the door over, and the rebar has pinned it against the door in that permanent position of the image. Remember, this is just there are two cantilevers here that meet for this steel here. Looking at the top view, and this would be the corridor, right? So let's go to the corridor. I'm going to make a right turn here. I'm going to come this way, and this is the corridor. This corridor here, this section here, has the two pieces of steel like that. We're looking at it here. And right about here is that beam 102, I believe it is, beam 102. It's a transfer beam, and there's another beam back here in the back wall. So it extends out, it cantilevers, and this one cantilevers this direction, and they meet there. When they hold on as much as they can, but they also load the floor. Keep in mind that if I do this wedge, see, I'm going to do a wedge here, like that. I get to do that wedge, this little triangle wedge, because that triangle wedge exists right here. It's missing from here to here, wedged. I showed that in my cardboard model video 5, I think it is, or maybe 4. Alright, I'm going to end this video. This just wanted to give you some content. Oh, I said I would get you, let's see, comments. So under exist here, the person stating a few things. But I said, I read your comments again. Ideal. Oh, okay, I meant to say I dealt with this wall in a video 1 or 2. I forget which one it is. I talk about the rotation and buckling of lower wall. You guys got to catch on when I say that. Go back to find the video. That wall rotates. When it rotates, it clears the ductwork, but the bottom part of it buckles, kicks down, and I said, there's the debris on the floor there. I guess exists. You didn't see that because I think you're trying to state almost as much there. I have yet to even introduce the data from the AC units. They reveal corridor information. Video is on the way. I thought I said more than that. Okay. Low wall. But this system has a twist and multiple buckles of wall. So when I put twist, that was my little Columbo thing. It literally has a twist, a rotation, a secondary rotation. There's multiple rotations in the roof, as we can see with the 12th floor to 11th floor. And then like 9th, 8th, and then it starts to straighten up a bit where it's more just a flat collapse. By then you're already getting pulled on, way getting pulled on by now by the other part of the building to the right is now part of this failure also. But remember, it fails from the bottom up though. The H beam, as it's called, but it's much bigger than H beam, and includes the kitchen area, which was enlarged from 4 feet to 5'8", I believe. It's a transfer beam down there, so it has that one support that kicks off, and the building rotates down. Remember, the back of the building is like a spine, it's trying to hold it together, and you watch the failure happen as it collapses down. It shears off the shear wall, the stairwell wall, and ejects it over to the parking garage area. You see it with the stair shape in the pad in the wall system. Ending the video. I have a lot more to come, but you know what? This is just what I call data stacking for you. I can't overwhelm you. Your brain would burn up. I don't want to do that. So I'm just data stacking. Just be patient. You get a little bit each time. Like this one has a lot of information in it. So you get a little piece, then another little piece, and then another little piece, and then I'll double back, go over it again, and I'll put it together a little bit more, sort of like this one again, going over the wall again, going over the rebar again. I'll double back quite a few times, and so it sets in, and then I'll just progress. All right, take care. Love you guys. Bye.